Scientific notation. Scientific notation is used as a way to write really large or really small numbers. And there's two parts to a scientific notation. There's the first part, which is a number, and I've got it highlighted here in green. This number right here has to be between 1 and 10. Okay, it has to be between, it's got to be a number between 1 and 10. Then this number will then be multiplied by 10 to a power of something, and that power can be a positive, it can be a negative number, but it's going to be a whole number. It's never going to be a fraction or a decimal. And if it's to a negative power, that means that this is a really small number. If it's to a positive power, that means it's a very large number. And the larger the power, the larger the number. The smaller the power, the smaller the number. So when you look at scientific notations, there's two forms. There's standard form, which means it's written out without the exponents. Then there's scientific notation, which is, again, you've got a number between 1 and 10 multiplied by 10 to the power of something. So what you're going to need to be able to do is to go back and forth between the two. If I give you standard form, you need to be able to write it in scientific notation. If I give you scientific notation, you need to be able to write it in standard form. So let's take the example up top. We're going to do two of them right now. Sorry, let me fix this so it's further away. We've got 3.3 times 10 to the power of 4. This exponent tells me what direction I go. If it's positive, I go to the right. If it's negative, I'm going to go to the left. So I have 3.3 and times 10 to the power of 4. This only works with tens because 10 is just a matter of moving your decimal places, multiplying by tens or dividing by tens. So that's why it works this way. So 3.3 times 10 to the power of 4, that 4 tells me I'm going to move this decimal place 4 places, and because it's positive, to the right. So the decimal's not going to be here anymore, but I'm going to move it 1, 2, 3, 4 places to the right. So the decimal's not here anymore, it's now down here, but I'm going to fill in the dips inside the dip with a 0. Don't put it up at the top of the dip. It's going in the dips with zeros. So that means that 3.3 times 10 to the power of 4 in standard form is 33,000. Okay, and if you actually multiply it out, if you did 10 to the power of 4, which is 10,000, and then multiply it by 3.3, you end up with 33,000. So this is a quick way of multiplying. 3.3 times 10 to the power of negative 4, again, we're going to start with our 3.3, and it's times 10, and since it's to the negative 4, that means I'm going to the left 4. So my decimal is not going to be here anymore. It's going to be 1, 2, 3, 4 places to the left, and I'm going to fill in those dips with zeros. So this would be 0.00033. And again, if it's a negative exponent, you have a small number. If it's a positive exponent, you have a larger number. Alright, so we've got this problem, and this is in standard form, and I want to write it in scientific notation. So the trick is to figure out where I'm going to put my decimal so that I create a number between 1 and 10. And if I look here, and I see, okay, I'm not going to start here, I'm not creating a number between 1 and 10. I keep moving it. 178 is not between 1 and 10, 17.8 is not between 1 and 10. But 1.78 is between 1 and 10. And then just to show you, if it's over here, it's 0.178, and so that doesn't work. So I'm going to put my decimal right here. I can then rewrite it out. So this is going to be 1.78. I do not need to write all these other zeros because 1.78000000 is the same thing as 1.78. Okay, so we're going to write 1.78 times 10. Well, now the trick is, okay, here's where I put it, here's where it would have been, because that's how you would write. You always start it at the end if there's not a decimal there. So now I want to see how many places it takes to move it back. So I'm starting here, and I'm going to have to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. So that means my power here, or the exponent, is 10. So this in standard form is 1.78 times 10 to the power of 10 in scientific notation. Alright, Here we have another example. This is in standard form. Again, I want to figure out where I'm going to put my decimal. And there is one here. So wherever I put it, I got to count it back to where it is originally, okay? And so the decimal would go right here because that creates a number between 1 and 10. That creates 8.44. It's going to be times 10 to the power of 1, 2, 3, 4, 5, 6, 7. I'm putting it back to where it originally was, but because I went to the left, I went from here to here, I went to the left, it's negative 7. And if you're ever not sure, just look, it's a very small number. This is a small number, so I know it's going to be a negative exponent. All right, now, sometimes you're going to have to order scientific numbers written in scientific notation from least to greatest or greatest to least. The trick is to start off by looking at your exponents. And so when you look at your exponents, you're going to say, okay, which one is the smallest out of all of my exponents? And so in this particular example, it's this one right here. So the smallest number that I have here is 7.4 times 10 to the power of negative 3. So I can cross that one off. I don't need to use that one anymore. Then I want to look at my next largest exponent. Well, it just so happens that these two have the same power. So next I'm going to look at the decimals, okay, and decide which one is the least between those two. And it is this one, 1.3 times 10 to the power of 2. So again, I'm done with that one. And now I'm left with this, which is 2.5 times 10 to the power of 2. And again, I'm done with that one. So here is your answer. These are the numbers written from least to greatest in scientific notation. All right, now, another kind of problem that I want you to be able to solve is fixing problems that aren't written in scientific notation. 28.7 times 10 to the power of 3 is not written correctly. This decimal needs to be right here so that this problem is written correctly. So this would become 2.87 times 10 to the power of. Well, here's the deal. It was going to need to go 1, 2, 3 to the right. Well, now I've added on another one, so now it's going to have to go 4 to the right. So I'm going to change that decimal to a 4. Because I moved my decimal here, I'm going to have to add 1 to my exponent there. Well, the same thing happens if you've got negative exponents. Again, I would want to put my decimal right here. So this is 5.578 times 10 to the power of. Well, again, it was going to be negative 1, 2, 3, 4. But now that my decimal's here, I can eliminate that spot right there, and it's just to the power of negative 3. And I know this is hard to write, and I apologize. But this is 5.578 times 10 to the power of negative 3.